for our monthly webinar. Today we have an exciting presentation featuring John Paquette from TIS Solutions, as well as Chris Patrol from Cashforce and Nicola from Cashforce as well. So that being said, John, I'll go ahead and turn it over to you if you're going to get us off.
Yeah, sounds great. Thanks everybody for joining today. Our presentation, Cash is King, but data-driven cash forecasting rules. So excited to take you through some of the more modern approaches to cash flow forecasting and really how you can use a data-driven solution to kind of, turbocharge your cash flow forecasting process, so to speak. Just a quick introduction of the speakers before we go ahead and jump into the content here. I'm John Paquette from TIS, as mentioned before. I'm VP Solutions for our US markets, so I oversee our customer onboarding team, our solutions architects, and our partnership engagement function as well. So joined TIS back in 2019, and really prior to that, all my experience was in the practitioner space directly, working directly in finance and treasury for a number of different US organizations. So very happy to be here today, taking you guys through these topics. With me today, co-speaking is Nicola Christian from Cashforce. I'll let him go ahead and introduce himself as well.
Right. No, thank you very much, John, and it's really a pleasure to be here with you today. So my name is indeed Nicola Christian. I'm the CEO and co-founder of Cashforce. I started with Cashforce, let's say, because of one idea that we had. Together with my other co-founders when working in private equity. So when we worked in private equity space, we found out about cash flow forecasting, working capital being manual intensive, and we thought there was a wide space to fill. So before that, I actually worked at PricewaterhouseCoopers and founded 2 other software companies. So really always excited day to day about anything that has to do with cash management, cash forecasting, merely from the product perspective. So really, keen to join here with John.
All right, great. Thanks, Nicola. Just give everybody a sense of the flow of the conversation today here. So we're going to take you through some of the historical challenges with cash flow forecasting, kind of talking through some of the root causes for why there's been a lot of dissatisfaction, a lot of cash flow forecasting processes, why it's been such a, difficult process for people to find an efficient way to handle. And then we're going to talk about some new approaches, right? So as the title suggests here, we're going to really focus on the importance of complete data in the cash flow forecasting process. And then some of the solutions around how technology can enable this solution, right? What has changed really in the market and within technologies to be able to support this so-called data-driven approach? I'll take you through these first 4 points here, really, kind of centered around the data component of this. And then I'll hand to Nicola to talk more so about, okay, you have the data. What do you do with it? How do you drive an efficient cash flow forecasting process from this? How do you draw insights from this data? So we'll talk a bit about how cash flow forecasting solutions in general have progressed. From the sort of one-size-fits-all type solutions, how to make the forecast in general more strategic, make it, less of a sort of weekly to-do, something that needs to be completed from a reporting standpoint, and to more use it to your advantage. What are the data requirements? So, we're talking a lot about data today. So what type of data should you really be focused on collecting to fuel this cash flow forecasting process? And we'll wrap up with some of these more, coming to market technology type topics that everybody's interested in. How can you incorporate AI and machine learning and things like that into your cash flow forecasting process? So obviously we have an ambitious agenda here, so I apologize in advance if we don't get to a Q&A session, but Nicola and I are always happy to connect offline if you have any additional questions on any of the topics that we discuss. A lot of them will hit very high level, obviously, just for the sake of time, so we're always happy to connect offline and go deeper on any of these topics in general. So jumping right into it here. Really the historical challenge with cash flow forecasting or treasury technology in general, what has really driven the need for treasury technology? Well, it's, sort of these foundational limitations that a lot of treasury teams face, right? So, historically, most treasury teams are 2 to 3 people, 4 people at most, right? Small teams. By nature, they're handling a very high volume of activity, payment and receipt and cash receipts. So they're, by nature, high volume sort of repetitive tasks. Very human reliant, depending on the level of technology adoption that you have. And they're sort of the overseers of, some very important data that needs to be shared throughout the organization in the form of banking data, right? That has sort of broad applications out of Treasury. And they touch some mission critical processes as well in terms of payments and reconciliation. So there needs to be a high degree of oversight and auditability around these processes. So, this sort of foundation for tasks, coupled with the fact that Treasury is probably one of the fastest growing roles within an organization over the last few years in terms of more and more responsibilities sort of being laid onto Treasury. has really driven the need for technology adoption. You know, looking back in the day, it was really, you had Excel, you had e-banking tools, and those were really the technologies that you had to rely on. And then, you know, TMS type solutions started coming to market to offer some more advanced functionality around topics like cash flow forecasting and sort of the breadth of activities most treasury teams have on their plate. So, you know, then you have technology and you're trying to adopt automated processes related to cash forecasting, reconciliation, GL posting, FX rate and interest rate hedging, payments, intercompany loans, netting, this whole, you know, skew of activities that's flowing through treasury. But I think that, you know, more so it's been the technology adoption has been really centered around a mindset of process automation and operational efficiencies, right? To deal with the automation of the repetitive tasks to be able to focus on the value add activities, right? So that's really where people have been focused on. And so as you take that into, you know, say you select a technology and you take that mindset into the actual implementation of that technology, you then very quickly realize that you have a whole bunch of functionality that's essentially useless without data, right? You can't perform any of these activities unless you actually have completed the integrations to facilitate the flow of data in and out of this system. So this is, you know, on one side of the equation, you got your bank integrations that's feeding your bank data in and out of your treasury technology. And then you have all your system integrations as well in terms of the ERPs that might need to receive, for example, reconciliation files, or, you know, more specifically for cash flow forecasting, that might be feeding your data sources that are driving your short-term cash forecasting assumptions, right? Your payables and receivables information. Likewise, you might need feeds into, you know, your financial reporting systems to drive your long-range cash flow forecasts. But, you know, long story short, this integration becomes the project within the project, right? It's, you know, in one sense, you want to focus on really the functionality within the Treasury application itself, but you have to get all these other variables sorted out in addition. And it sometimes clouds sort of the more operational efficiency type items that most organizations are looking to undertake. And most reach a certain point and they say, it's enough. You know, we got 75% of our banks connected. We have one ERP connected, our main ERP. Maybe we just sort of cut it off here, and, you know, we'll try to improve things as we move forward. But, you know, I think we've spent enough time trying to get this together here, right? So for some processes, this isn't necessarily, you know, a deal breaker. If you think about, for example, the reconciliation process, if you've gotten connected and you've automated, for example, 70% of your cash reconciliations, that's only 30% you have to do manually now, right? Or if you've increased the level of straight through processing for your payment activity and reduced manual payments in any respect, you've eliminated risk, you've, you know, brought efficiencies into the process. But from a cash flow forecasting standpoint, if you only have 70% of the data, it's essentially useless, right? There's not much you can do. There's not many insights you can draw from 70% of the picture about your cash flow forecasting process. And that's why this becomes so sort of mission critical and data dependent. You know, as you think about sort of the impacts of these partial implementations on cash flow forecasting, essentially where organizations ends up is they need to take the data that they've automated, right, that's 70%, and then combine it externally with other data sources to be able to get the complete picture there. That's a really labor-intensive task. The quality of the data suffers, you know, because you're using multiple different sources. You don't know if it's, you know, sort of consistent data across the board. You lack those operational improvements. The time to forecasting is drawn out, right? Cash forecasting becomes, you know, something that you start on Monday and you hope to finish by Wednesday versus something you can do more, you know, on demand and act strategically around. And you kind of diminish a lot of those benefits, right? And I think that's what's driving a lot of the dissatisfaction currently in the market around cash flow forecasting. So on this slide, I threw in a few different survey results. If you look across the bottom of the screen here, first two come from a 2021 Strategic Treasurer survey here, and you can see, starting with the one here on the left-hand side, only about, you know, 50% of organizations characterize their cash flow forecasting process, you know, the process to generate the forecast, as being either extremely difficult or somewhat difficult. And only 2% characterize it as being extremely easy, right? So, and as you move on to the next graph here on the bottom end of the screen, those using an ERP or TMS or some sort of technology solution to complete their cash flow forecast, 19% are satisfied with that process. With Excel, 17% are. So there's not a huge difference there between, you know, those adopting technology and those not adopting technology. And then if you move into, you know, those that are somewhat satisfied, you have, you know, 57% of TMS or ERP users being somewhat satisfied versus 42% on ERPs. So there's no question that technology has improved the process, but it's definitely not, you know, mission accomplished. This isn't something that's been solved, and it's, you know, it's not an easy process for everybody involved. And so if you look at the next graph up here on the top right-hand side, what's hindering this process? What are the obstructions to creating a forecast? And it's all data topics, right? The top two here are data gathering, the process for just accumulating all the data that's necessary to build a forecast, and data preparation, the process of getting it all in the right format to be able to actually derive insights from it, right? And so, it seems like quite essentially you have a sort of a data problem here for the cash flow forecasting problem that's preventing organizations from generating the efficiencies that they would really like to. And so it just makes sense to go with this data first approach, right? This is, sort of the topic that we are centering this conversation around today. And, if you think about the data first approach, there's two things you have to think about. It's first of all, how are you going to get the data, right? The critical data that you need. And then secondly, how are you going to make that data accessible throughout all the applications that really require it, right? Those are two of the components to really think about here. So when you're thinking about how to get the data, I guess technology that's going to enable you to get the complete picture, right? Leveraging solutions that are able to pull in all of your information, starting foundationally with your balance and cash flow information, which is, sort of the heart of the cash flow forecast. You need to know where you're starting before you can forecast where you're going to end up, right? For the starting cash position. So this is obviously mission critical to have the complete picture here. And then all the different data sets that ultimately feed into that forecast, which is generating from the ERP system in terms of your payables and receivables information, driving your short-term cash forecast, your financial reporting system, your more financial statement forecasts that are driving your long-term forecast, and then data that's going to help you calculate critical metrics like DSO, DPO, that's ultimately going to help you take those financial forecasts and derive cash from those, right? You have to kind of figure out how you're going to obtain all those different sources of information. And then you have to figure out how you're going to make it accessible throughout the entire organization. And honestly, we could probably spend a whole hour just talking about data aggregation strategies and data valuations and things like that. But, there's commonly two approaches that I'm seeing organizations take these days. One is the data lake, right? You take all this information and you synchronize it to a data lake and you normalize it so that any application needs to leverage it is able to do so. That's a pretty sophisticated approach, maybe reserved for those that are pretty far along on the technology curve. Or you select so-called, best of breed solutions that are able to make this data more accessible via APIs, right? That's probably the way that most organizations try to do this these days. And, by getting very specific about API integrations, you can plug into really detailed data elements. You can update them more frequently. You can, kind of break down these historical organizational silos that drive a lot of this inefficiency and the cash flow forecasting process and beyond. And, the advantages of this approach are twofold, I think. First of all, you solve the completeness of data issue that plagues the cash flow forecasting process historically, but you also become sort of agnostic, right? You've solved the data picture independently of any sort of treasury technology, and then you can leverage whatever you want to on top of that. For example, if you really like a particular TMS's approach to cash flow forecasting, you can leverage the data through that, or you can use the best of breed cash flow forecasting solution to get a lot more advanced functionality, scenario analysis, have a more robust strategic forecast. Or if you want to, you can build your own solution for cash flow forecasting out of Tableau or ClickSense or some sort of BI tool if you have the capabilities internally, or migrate sort of sequentially through these different stages of technology. And then the other one is it prepares you for, coming to market technologies, I guess, right? So a lot of people talk about, and I know Nicola will talk about this later on as well, AI and machine learning and pattern recognition and the role of that in cash flow forecasting. Something to keep in mind about that technology is it really relies on a complete data set. To be able to work efficiently, right? You can't derive patterns in an incomplete data set that you expect to translate to business insights. They're going to be the wrong patterns, right? They're not going to be the complete picture for the organization. And, real-time cash management strategies, which everybody is very, very focused on now these days, are facilitated through near instantaneous frequent updates, right? That can really only be facilitated through API connections. Bank APIs and software integration APIs. And this is exactly sort of supporting that approach as well, right? So moving on here, why is this now possible? Well, this is a bit of a extremely technical diagram here, so I'll try to go over a very high level. But the point I'm trying to make here is that these solutions aren't just all of a sudden we came up with this data first idea and it's sort of more of a marketing thing than there is any sort of meat to it. But it's more so how applications are built and hosted these days that are actually allowing this to happen for companies. So the easier part to explain here, I think, is on the bottom side with the evolution of cloud technology. you think about historical hosting models on-premise, if accessibility of data is really hindered through an on-premise model because the application itself can only access the data and synchronize data between different applications that are also on-premise, unless you have some sort of very complex proxy setup to push data back and forth a broader network. You move to platform as a service, function as a service, cloud hosting models, all of a sudden that data is all in the cloud, right? And that application's in the cloud and it's able to be more universally accessed, right? So that's kind of step one in unsiloing the data, so to speak. And then the way applications are built, the historical monolith application is really built in a way that it serves itself. Everything supports the function of that application. You push a button and something happens on that application, but it's not built to be open, so to speak, right? But applications these days, or so-called best-of-breed solutions at least, are built based on microservices, which is essentially a series of different services within the application itself that are all connected through API. And it looks and feels just like one application, but it's actually these mini services that are all communicating with each other through API. And what that allows you to do is then also through external applications, connect into those services so that you can, receive and push and interact with data at a very detailed level. So it's one of the key reasons why, best of breed solutions are best of breed, and why historical monolith applications will likely never be best of breed unless they're broken down into this more defined service structure, and is definitely a big consideration for people to be aware of as they're looking at this data-driven approach and sort of facilitating this flow of data. So hopefully that wasn't too technical, but I thought it was an important point to make here. So, and then just the last point here on this slide is just the trends for that we're seeing in the market. I thought were interesting to highlight here. These results are actually based on a survey that we launched at TIS with a survey partner, where we looked at some of the forward-looking trends for 2022, what people are really looking to adopt for technology and what sort of impacts they're looking to get out of it. And we kind of sliced and diced this a few ways by industry and by organization size. But I thought this particular finding was pretty interesting in general. So, among the desired impacts of technology for 2022, why organizations are upgrading their technology. If you look at the impacts that the small enterprises are looking for, those that are highlighted here in purple, you can see it's improve systems used by my department and automate manual and repetitive processes, right? But if on the other side of that, if you look at the enterprise level organizations, their main objectives from their data, their technology investments are to gain better visibility and insight into their data to drive better decision making. So it's sort of the point that I made on the very first slide here, is that that's sort of step one in the technology curve, so to speak, for Treasury adoption, ends up really always going towards automation, right? Automation, systems efficiencies and things like that. But if you look at enterprise level organizations who have probably progressed a little further on the technology curve, just by nature of Treasury technologies, back in the day, it was always, only enterprise level. The Fortune 150 had TMSs. There was always the comment, we're not big enough for a TMS. SaaS solutions changed a lot of that, but still enterprise level organizations definitely got a head start. And they're already sort of adopted this data first strategy, or at least are preparing for it in 2022. So I thought this was interesting. It's definitely something to keep an eye on, I think, as you're looking through other survey results as well. But the point I'm trying to make here is that it doesn't have to be this way. This data first strategy is really available to all. It doesn't take data scientists within your organization to kind of put this in place. It's sort of what SaaS solutions have sort of solved for organizations, and in particular best of breed solutions. So definitely keep this in mind as you're sort of looking at your cash flow forecasting structure and sort of how you build that sequential sort of improvement on the process if you do go data first. So, and with that, that kind of concludes the data portion of the presentation here. Nicholas is going to take us through a few of the sort of practical applications that now that you do have the data, what can you do with it? How do you drive an efficient forecasting process? So I'll hand over to him.
Great stuff, John. So love it, I think, in terms of the technology and the data angle. So I'll turn the table and let's say get into the functions and functionality part. But maybe just if we ask ourselves, like when we ask treasurers and CFOs, is cash flow forecasting actually a priority? On the next slide, you'll actually see how sort of the top 10 priorities when you would ask CFOs and treasurers actually look like. So these are two PwC global treasury surveys. On the left column, in the left column, you see the CFO's top 10, and in the right column, you see the Treasury's top 10. And interestingly, the cash and liquidity are in both cases in the top 2. And then we have working capital stacking up as number 6 here. Now, if we move on to the next slide, we have another quote here actually from McKinsey. It's actually a very recent one, where I picked it up from an article that I was reading, and it was really about how transaction banks are reinventing their treasury services. But when we read a little bit closer, it actually stated something very interesting about cash forecasting. So it was cited here that it's very much like an inefficient process by small and large organizations alike. So I think it very much confirms ultimately what John you were explaining earlier, and that this market for solution providers were able to solve this problem specifically. Let's say instead of opening up ultimately as we speak. Now, if we go to the next slide, and remember we said like how can we benefit from cash flow forecasting solutions? Of course, there is automation. So if you go to the first pillar, we save time, we consolidate data, and we try to cleanse the data. We try to ease the workflows to organize submissions from all the different entities. We try to manually input the data. So a lot of the focus typically in terms of the benefits is always in the first place on the time savings. But as John mentioned at the start, we really want to elevate this to a more strategic level. And when we then load the 2 other pillars, these are about proactive cash savings. So let's assume that we have a forecast which gives us a lot more granularity, which gives us a lot more insight. Then ultimately this will get us to better decision making on facility usage, on investments, and how we better allocate our cash. But of course, this would need to come through more accuracy. And as we will see later, accuracy, of course, has to be a result of the better use of data, the better use of the logic, and maybe even smart techniques to improve that forecasting accuracy. Where we think that it really goes to another level is where you also would like to analyze working capital insights, working capital drivers within the data, because you have now all that data, but within the data you can project cash, but equally you can project working capital. You can project working capital drivers. Think about how you pay your vendors. Think about customers that pay you, and of course they have certain patterns. They have certain evolutions in there. And I think when you go to that level, that's actually when you're trying to combine the cash story, the working capital story, and this really gets to a very more strategic level than just a weekly task of producing a cash forecasting and cash forecast and reporting that to CFO or board level. This is about analyzing the data that actually produced the forecast, but trying to understand how it can influence working capital short and long term. So this is a way to think through the more strategic benefits on cash flow forecasting. So if we go to the next slide, a lot of us might ask by this point, like, hey, but what is the difference now between the niche cash flow forecasting solutions on the one hand side and the TMS on the other hand side, so the all-in-one solutions? And of course, what is important to John already mentioned on the more technology side, sort of what that difference is. But if you look a little bit under the hood, that technology, of course, produces certain functionalities. So on the functionality side, you there see typically quite a difference in the way that the data is being handled and absorbed by the system. So not going through all of them, but you can see here on the left-hand side different requirements, and on the right-hand side how a niche solution stacks up against a TMS. And when you think about the first line, data extraction out of ERP, the granularity of the data is a big difference. And I think John talked about that quite nicely when he talked about the microservices architecture, the way that everything, is really rambled on top of this really large large base of data. Well, that's exactly when you look at a niche solution, it will go more granular. It will keep the granularity. It can absorb it, and the database itself behind will not, let's say, be exploding because of the data. Of course, on the TMS side, you would have more like a summary level of the extraction from ERP, giving a good look on your ledgers, but summarizing that. Not 100% allowing you to go to that strategic step that we talked about. Now, the other pieces on this slide ultimately are describing things like workflows, short-term versus long-term forecasting, applying specific techniques, scenario analysis, specific techniques on AI and machine learning, scenario analysis, which are typically more native than, of course, the more configuration or customization that would be required from the TMS side. And I think the last row here, again, working capital analysis, is a big one because it refers back to the slide before where you had DSO, DPO, and cash conversion. It's sort of a more strategic element that is part of a more niche solution because of its granularity, because of the data that you use there, versus the TMS solution where you would only work with summary level data. So I think that's really on the more, as an evolution from the technology, looking more to the functional differences. So if you go to the next slide, let's take a step back and think about our maturity level and the data that we would need for each of those maturity levels. Now, when I talk about maturity level, it's more about what type of maturity does the forecasting process have. Now, here you see from low to very high. Now, on the low end side, you would have no formal forecasting process. Sometimes it's an ad hoc process to construct a forecast. Now, when you move a little bit further, the medium version of that is that it's very manual, it's Excel based, but at least there's a frequency. At least there is a repetition, there's a repetitive task of making a forecast, but there's very little to low usage of actual ERP data in there. But there is a construct of getting data together from different entities, whether that be business units, whether that be legal entities, but it's very manual, very Excel driven. Now, when you go to the right, again, one step high, that is a forecasting process where you already use ERP data into it, meaning you do extractions from ERP, you try to go through the ERP lists, the open items, you try to manipulate potential open items that you don't find in the right spot. But at the same time, there's no real sophistication behind that. So it actually is still very manual, but at least you're leveraging the ERP content and you're leveraging a data source that's valuable for this process. Going another step to the right, this is where it gets very high maturity. And this is where techniques like AI and ML can really come in and make it more sophisticated, but also more automated. Because think about the high phase where you're trying to understand what is payment behavior across your customers. Pretty important factor for a forecast. But if you do that manually, and then that is typically like a one-time calculation, you can automate that calculation, but to really make it smart, that's when you go to that next level. Now, if you go from left to right, it also increases dramatically the amount of data points that you would need. In the very low side, you don't repeat the process too much. You would need an ad hoc data flow, and typically you wouldn't potentially have the data prepared in such a way. So you cherry pick the data. If you go all the way to the right, we all know that the data required for AI and ML to really work is quite proportioned. So this is really already just showing you, think about where you fit, and of course the data that you will require. Moving on to the next slide. A very concrete example. Why don't we take a look at this case? So this is a case of take a do-it-yourself or a fashion retailer. One of the first steps typically in cash flow forecasting is understanding the data, but also understanding, first of all, the cash streams. So before we even talk about the data, this is about understanding the cash flows, the streams of cash going in and out. And in this simple example, you have shops, you have stores all across the country, maybe in different countries. They receive cash, credit card, voucher payments. But you also have, on the other hand, salaries, the rent for these shops, and of course, the suppliers for all the goods being sold in the shop. So it's very important here to also indicate there's some treasury funding, investment projects that are happening. So also generating the cash outs. and then the loans and interest, of course, with banks. So the interesting part is, if you make a sum of all these different cash flows, the question now becomes, where's the data? So how can I fill each of these cash flows with data? And that's on the next slide. And if you go to that next slide, you'll actually see that each of those elements will be fit by a piece of data. The question now is, where do you put it in terms of short-term, mid-term, and long-term forecasting? So you see here short-term, mid-term, long-term, and you can see that on the incoming side, the inflow side, you might have daily budgets or a budget per store per day, where you take into account Christmas holidays, where you take into account bank holidays. And on the other hand side, and onto the outflow, if you go a little bit up to the right, you have purchase invoice and purchase orders. These are pretty critical because these are very valuable data points that will tell how the cash out will be constructed. And that will then be fulfilled by a P&L ranging a little bit further into the future. So by that smart combination of using ERP data and P&L data, a sort of longer term horizon can be filled. And if you go all the way to the top, you might have just manual inputs and overrides. That's the nice thing about forecasting, I guess. It's 80-90% is really can be automated in terms of the data, but there will be always that bit where the human element plays a big role into it. The last but not least, we have a few transactions between the parent company, the different stores that might be stored in your TMS. So here's where ultimately the data from ERP, P&L, and TMS can actually, and the manual input, not to forget, can flow into these different cash streams and into these different horizons taken there. So maybe Nick, go to the next slide. So once we get the data and we maybe want to transform this practical example into like a bit of a layered model. So if you let flow the animations here, John, you'll actually see that on the actuals, of course, we can take in bank statements, we can take information from your ERP. But on the right-hand side, you see these different layers. We talked about ERP, we talked about P&L, talk about TMS, and then even further, we talk about taking trends from the past and pulling them forward, and we talk about manual adjustments. I guess the key message here is that when we look at the data streams from this do-it-yourself retailer, we transform into different type of data elements. If you then put them right on top of each other, you have what we call sort of a layered model to pull all this data together and to pull actually a forecast together. And if you go to the next slide, right. So this is the point in time where you say, well, we have all this data together. The question is now, can we actually use AI or machine learning to go to that sort of next step, or that from what we said, high maturity to very high maturity? And I guess the way we think about it is AI is a very big buzzword in the market. Like everyone uses it. Everything seems to be kind of AI and machine learning, but very few applications sometimes are ultimately driven 100% by AI. There's maybe the human element, but there's also maybe just some simple statistics that come into play. So these are a few slides that try to make the difference between just simple statistics and what is really AI and machine learning, and what are the pros and cons. Because we can also say that it's a very, it's a very big buzzword. It's being used all the time. The question is very simple, like, does it really help? So these are two cases, I call it with the case studies or examples where AI can help the forecasting, and that's one on the one hand time series, and the other hand customer or vendor payment behavior. Now, in focusing on time series, if you go to the next slide, you can see a very simple example here. These are actually two examples where if we look to the green curve is displaying a historical data set of a certain cash flow. Let's assume the receipts that we get from our customers. Now, if you go on that left graph to the right, you see there's a red graph on top of it. So what this is actually telling is that based on the green part on the left, it's trying to extrapolate that data set to the red line on the right and trying to see if they measure that against the actuals, if it actually holds up. And in this case, you see that it's a very nice fit to the curve. It wouldn't necessarily go and check out all the outliers, as you see, right? It doesn't go to the highest peak, but it's a nice fit. And below you can actually see a backtest variance of 1.7% difference, so which is phenomenal in a way. On the right, you can even see an even better example where you extrapolate again the green curve, you get to the reddish curve, and that if you compare it to the green part, you have a very small variance. Now, two enormously successful potential examples here, but how are they generated? How do we extrapolate a curve from the past? And you will see that on the next slide. In the way this example was, for example, built was by combining different models together. But if you look under the hood, if you go on the left-hand side, and this is maybe a bit technical, but FB profit, MA adjusting trending, like the fifth line, these are in fact statistical models. But if you mingle them with maybe some more machine learning models like NBeats and temporal fusion transformers, and you choose the better working model either manually or either by voting mechanisms, then it's what they call you produce an assembling engine. And it's very simple. You get an input flow and you get an output, and the engine will just select the best algorithm for your curve. So it's in fact pretty simple. But, and this is the next slide, John, the question here is, do you really blindly trust the black box? Because what I described was a series of machine learning algorithms that and statistical algorithms that you might manually select, or you might even say, well, let the machine select the one that's best. And the question poses itself, like, are we now trusting all the black box? And on the next slide, we just wanted to provide a couple of, call it attention points. So first of all, when you use data, this data is produced outside of a very controlled environment. We all know these are cache ins and or outs that could be completely random at some point. It could include various outliers. And this relates to the second point. It's all based on historical data in this case, if you extrapolate, if you build a time series. So the third point is also related to that. So the call it danger of having the model being biased is extremely high, of course. And the fourth point is related to this black box principle, is if you have data, if you have a model, how do you interpret the output when you don't exactly understand how that model is operating? This is, I guess, the caveats with every AI model or every AI story. Somehow it does something, maybe magically, but it does something on the basis of data. So that has to be correct, clean, and big enough as a data set. And then it produces an output of something that we try to understand, but it's not always easy. So I'm just giving, I guess, the pluses and the minuses. It can be extremely powerful and automating, but on the other hand, we need to be aware of what we're doing. Now, if you go to the next slide, there's another example, and some of you might like this example a bit more because it's maybe closer to our heart when we produce a cash flow forecast. Is we try to estimate how our customers will pay. Now, if we do that, John, going to the next slide, we all know that customer payments could be skewed. So this is a simple graph where we try to what we call identify features of payment behavior. And this is one feature. This is saying, when does our customer pay? Middle of the month, end of the month? It does seem very specific here. Most of the invoices are paid middle of the month or just after, maybe it was a weekend, in terms of the day itself when it was paid. Now, this insight into this data is quite helpful because think about the machine now identifying this. The machine at least can skew the potential payment date a little bit further towards the middle of the month. If you go to the next slide, you see another example where you can look at the day in the week. Is it a Monday, a Friday, a Wednesday? Is that an important factor to the payment? And the difference between the bottom and the top slide is more related to the number of invoices versus the invoice value, which is interesting because you would see a lot of invoices are paid on Tuesday, but if you look to the bottom, the invoice value is very minimal. So you can see there's a skew there to pay the big amounts on Wednesday and Friday from the same customer. So if you think about those 3 features that we just discussed, and if you go to the next slide, a machine learning model will typically take in these features on the left-hand side: amount, due date, billing date, previous year behavior, disputes, and will that actually combine into a model? If you go to sort of the next animation, you'll see that these features are then put into what we call a feature-based prediction model, and it will also try to sort. Such a model will typically sort the importance of the features on the left. And when you run these, it will be interesting to watch for every customer, how important is the amount on the invoice for them to pay? How important is the number of the week? How important is the day of in the month for them to pay? So, if you think of it and you compare now the extrapolation techniques, which, kind of is a way black box style. This is less black box because you get a lot of more information on customer behavior and what influences it and what not. But keep in mind, of course, there's still the bias, the danger of getting biased, and the danger, of course, of using sometimes polluted data. But as you can see here, there's a lot of, let's say, information within the data that can be harnessed. So if you go to the next slide, let's talk a little bit about forecasting accuracy. I guess some of you may know that a lot of us are floating through the air the percentage of accuracy of our forecast. Is it 10? Is it 20? Is it 5? Is it 40%? Or is it 90? Is it 100%? So there's a lot of, we'll talk about that in a second, what are sort of the measures typically. But let's assume we think about a generally known measures in terms of accuracy. On the left-hand side, there's the y-axis, and we think about the effort on the x-axis. If you think about the exercise that we all try to do, we try to improve the forecast accuracy. Now, here you can actually see in the beginning, it's little effort to take to a steep push in terms of accuracy. But once you go beyond a certain point, as you can see the 2 points noted on the graph, you'll see it requires really a significant effort increase, time spent, versus the accuracy that you can improve. And that's the, I guess everyone knows that if you want to go from 90 to 95, it takes a lot of more time than going from 70 to 80 or 70 or 7 to 75. But that's an important point when you evaluate your current forecast accuracy versus your target, because that's really, it's really worth investigating. What is your target? Where do you want to get to make good decisions, and how much time and effort is going to cost? So this curve will look different for everybody, but it's clear that technology, of course, is a big enabler to make sure the curve at least can, let's say, can be a little bit less pessimistic as this one, so that at least you don't need to spend that much time to improve accuracy. Now, about accuracy, the next slide will we'll get a little bit deeper into that. Now, when you go to the right and you think about accuracy outputs, we talk typically, in our common language about 90% accuracy. The question is there, what does that actually mean? And if we think about that, there are even different metrics. Some of you might hear about MAPE. If you worked with AI and ML, is the mean absolute percentage error. It's a very simple calculation. It's called actuals minus forecast divided by actuals. If we, let's say, I would say generalize it, but then you have root mean square error and the variance volatility. The question always is timing. Across which time do you calculate that? Is your accuracy measured across 3 months? Trailing 3 months? Is it an average across different measurements points? Or is it basically just 1 day? Because we all know that it's very difficult to get 1 day right, but maybe to get the 3 months right. Another typical misconception we sometimes hear is, are you measuring balance levels? Or are you measuring net cash flow levels? And trying to make a good distinction there is key to understanding if we're comparing apples with apples. Because if your competitor in your industry calls you up and say, hey, we have an accuracy of X, are we talking about the same X? On the total left-hand side of the slide, we talk about data considerations. And this is where I kind of link it back to what John mentioned at the very start. Data is the fuel here, but the question is, what is the data quality, the granularity, and the availability, or what kind of data do we have available? And it all starts with that in terms of applying forecasting methodologies. Now think about the input of the data is one, but also the output. What are the horizons? What's the granularity and what's the frequency? Is an equal data consideration to be done. Now we talk about accuracy, and the big caveat I always mention is it's not the only measure of success, and that's exactly to John's point as well. The data itself and the exercise itself will typically, improve the organization, will have strategic benefits into understanding a lot of other things. So your accuracy can be off by a mile, but in fact, the data insights can bring you to optimize procedures, working processes within the organizations. We've seen even order to cash and purchase to pay improvement just because of making a forecast. This is where it gets really strategic. I think if we go to the next slide, there's some lessons learned. And this is, I guess, if we pull all the cash forecasting lessons learned together, if you can see, the first 3 points are all about data. So the fact that if you start an exercise to improve cash flow forecasting, there's a mindset requirement, there's a skill set requirement, and a resources requirement. So everyone knows we need a bit of resources to look at data, but the skills and the mindset is critical here. So anybody that is looking at this like, wow, it's a lot of data. How are we going to cope with this? Should of course think about the benefits and think about maybe this data can be really valuable to the organization. And this is when it comes to the next point in terms of data quality. A lot of us would say, well, we're not considered to do anything about our forecast because our data quality is off. That's, I think, one of the most heard comments when it comes to using data for forecasting purposes. But this is the typical chicken and egg problem, because if we don't look at the data quality will never be improved, and it ultimately will lead to no forecast at all or no accuracy. And we've seen a lot of projects actually succeed by, I guess, taking off the ambition of being accurate in the first 3 months, but really trying to look at the data and to see what it actually harnesses in terms or has in it in terms of value, getting that value to work, and then improve accuracy over time and true data quality improvements over time. Understanding the data drivers and sources, that's, I think, what we did with the example on the do-it-yourself retailer. That's a key lesson learned. If you dive head first into a data set, typically that would be just trying to look for a needle in the haystack. The best thing is really to think about this up front, about what are the data or the drivers of my business, what are the typical sources where I'll find useful information to accompany or to accommodate that driver. This is really, really critical. And then the final piece that we'd like to share is without proper buy-in of the stakeholders in this process, of course, we need the stakeholders to be believing that this exercise will actually give the fruits that it might actually give. And I think process or change management, are just critical to such processes. So I think, John, that concluded as well a little bit of the more practical look at cash flow forecasting.
Yeah, thanks very much for that. Those are some great points made there, both about what you're looking for in a forecasting tool and also how to make the most of it, and the value of the tool beyond just being accurate in your forecast. So very good points there. At this point, we definitely want to open it up to any questions the group might have. I know we covered quite a few points along the way here, and a lot of these topics are probably a little technical dense. We tried to explain them as simple as we possibly could, but I mean, we're more than happy to stick around here for a little bit longer and answer any questions the group might have. And to ask those questions, feel free to just type them into the chat box here. Okay, it looks like there may be no additional questions here, so that's fine as well. We also wanted to provide our contact information on this last slide here. So if there's any other questions after you get off the line here, if something jumps into your mind that we said during the course of this conversation, feel free to reach out. Nicola and I are more than happy to kind of continue the conversation. Or if you want to go deeper on any of these points in particular, whether it be on the data side of the equation or the forecasting side of the equation, we're happy to kind of pick up the conversation there. So, otherwise, thanks everybody. Thanks everybody very much. We just got I thought we got a question, but we more got a thank you.
Actually, John, I do have a question, and Nicola. Well, first, thank you both for presenting today, and thank you, Jeff and Kevin, for putting this together for New England AFP. As a practitioner, I am curious as to how long it might take to do an initial survey or evaluation, and then an implementation of a process like this. And then, if you wouldn't mind, talk a little bit about the what you guys bring to the table as not only the consultants but also the product, and how does that product and consultation work with, say, a company with SAP, and they may not have a treasury management workstation. I couldn't put that into writing in a chat, so I had to ask that. Thanks.
Yeah, no worries. So I mean, the length of time for just putting together a plan for how to attack a concept like this probably depends a bit where you're starting from, I guess. You know what I mean? How much history you have from a data standpoint. If you have any sort of tool in place today for collecting data, even if it is partial data, that kind of lends into the equation as well. And if you're looking to, I guess, integrate with any existing solutions that you're using either for data aggregation or forecasting purposes, that's part of the process too. So yeah, there's quite a few evaluation steps here, but I mean, I think most organizations, they could progress through that pretty diligently, and kind of, with the help of somebody, a provider could assess where those different functionality gaps really are in terms of what's preventing them from achieving their goals, what are those goals, and what's preventing them from achieving them. They could put it in place to really kind of plug a lot of those gaps within, I don't know, Nicola, would you say 2 to 3 months would be kind of a realistic assessment? So I'd say that would be a practical approach there to kind of beginning to plug some of these gaps. And as far as integrations with systems beyond a TMS, something like SAP, we work with a lot of organizations that are doing, for example, S/4HANA migrations right now. And SAP is providing, I know, a pretty robust set of finance applications to go along with that. A lot of organizations are looking at those applications because now they have a cloud-based ERP they can roll out globally, and they can standardize processes globally. It's the first time they've been able to do that, right? From an ERP migration standpoint. So yeah, these processes work equally as well with that, is sort of what we found. I know, not to plug our own product so much, but TIS is a certified SAP partner, for instance. So we have a certified integration plugin that's able to facilitate the flow of data into SAP. We have customers who are using us as the supplier of data into that system to drive financial processes, and they're also using it for hosted data lakes actually on the HANA Cloud. So it can kind of go full circle through the SAP application, if that's your data aggregation type strategy. I haven't heard of many, if any, I think, customers actually using SAP for cash flow forecasting purposes. I don't know, Nicola, if you have maybe, but that's one opportunity I think that maybe to supplement. You can use SAP as sort of your data aggregation hub in a lot of nice ways, particularly with HANA technology, but you still might want to think about the robustness of your forecasting tool in comparison to what might be available out of the box there. So
I'll probably add to answer a couple of the side questions perhaps as well. We tend to think about it like a walk, run, fly approach, in the sense that you start slow, you try to put a couple of things in place very quickly based on the data set. And I'll give one example. With Kellogg's, there was a case that they've done there. So Kellogg's is, of course, a pretty big company. They had 4 SAP systems. One of their SAP boxes was connected in about 6 weeks' time and provided a lot of output that let the Kellogg's people really see that there were benefits. So they literally saved millions already in the first 6 weeks because they could find within their working capital data gaps. And in the next 6 weeks from that, of course, set up the forecasting like John was mentioning. So I guess the technology piece that's important is that SAP extractor or SAP plugin where John referred to, because then it goes quite quickly to get the data automatically, to also normalize it, because you would think like, wow, how much work would that cost to do? But that plugin ultimately automates that process. So the beauty of it is that you can actually very quickly look at the data, like in Kellogg's case, and very quickly find out with a lot of dashboards analytics where your data sits, how good it is, you know, where you need to plumb or not. And in their case, actually, it was the data quality issues that brought the actual savings in the first 6 weeks. They saved millions in the first weeks and then progressed from there to actually build their cash flow forecasting in the next months or so. So, but like making this an interim step to say, look, connect it to the system, look at the dynamics in the data, and then progress from there. For me, that's like the ideal approach because you save time at the start, you save already money by seeing things that you say, wow, this is actionable, and then you progress to put a cash flow forecasting place in the next months from that.
And lastly, what's the normal time period or term for your forecast? Are you doing a 13-week, 12? 13-week? You're doing a 12-month. What would be the typical again forecast? What are you trying to do? Both?
Yeah, so there's like the very short term, like the 2 weeks. Then you have the 13-week, the typically 13-week rolling. That would be the pretty standard one, and then 12 months as well. So 6 to 12 months depends a little bit on the company's vision to do so. Now, of course, so 13 weeks is like typically like a bit of a standard for everyone to absolutely do and to have that rolling. Typically weekly granularity, and you execute it weekly as well. Like you execute the process weekly. When you make the 12-month forecast, you maybe do that on a monthly basis with monthly granularity. If you do that, let's say in terms of direct versus indirect, what I'm talking about mostly is direct. It could be that the FP&A team makes an indirect version of that 12-month forecast as well. Okay. So I kind of want it to be complete, so that will be the complete version of it.
Excellent. Well, thank you, gentlemen.
Thank you. All right. Any other questions from the group? All right. If not, I mean, I think that concludes our presentation for today. We very much appreciate everybody who joined to listen to us. And yeah, feel free to follow up if there are any questions to come up once we get off the line here. Thanks, everybody.
Thanks a lot, John. It was a pleasure to talk with you. And yeah, great day for everyone. Hope you had a great lunch.